Hello guys, good morning. Welcome back to our YouTube channel, Maths Tutorial by Dibesh Sir. We have discussed the basics of matrices in our earlier videos. You can check them through I button. In this video, we are going to learn about determinant of matrix, adjoint of matrix, and some example. So let's begin our class. First, determinant of matrices. Determinant of matrix A is denoted as mod A or det A. For example, A is equal to 1, 5, 3, 2, then mod A or determinant A is equal to determinant A 1, 5, 3, 2. So here we have to multiply first principal diagonal, then minus with, then subtract with secondary diagonal. That is 1 into 2, 2, minus 3 into 5, 15. So 2 minus 15 minus 13. So we know that mod A is always positive, but determinant can be positive or negative. Next, theorem for square matrices A and B. Determinant of AB is equal to determinant of A and into determinant of B. Next, remember that. Adjoint of matrices. For a given square matrix, if we replace every entity in A by its cofactor, then transpose of this matrix is called adjoint of A and denoted as adjoint A. Remember that. If we replace every entity in A by its cofactor, then transpose it, that matrix is called adjoint A. For example, if A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33, its cofactor are A11, capital A11, capital A12, capital A13, similarly. But their transpose means row changes to column, that is capital A11, capital A12, like this, capital A13, capital A21, capital A22, capital A23, capital A31, capital A32, capital A33. Then that matrix is called adjoint A. Note, to obtain adjoint of 2 cross 2 matrix, first interchange the element of principal diagonal. Interchange the element of principal diagonal means D comes here and A comes here. Second, change the sign of secondary diagonal. If this is plus B, then it is minus B. If it is plus C, then it is minus C. So clearly, if A is equal to A, B, C, D, then adjoint A is equal to interchange the principal diagonal, that is D comes here, A comes here. So D, A, and sign changes of sign of secondary diagonal changes, that is minus B, minus C. Example, if A is equal to 4 minus 2, 1, 5, then adjoint A becomes 5 comes here, 4 comes here, and the second sign of secondary diagonal changes, that is plus 2 minus 1. So clearly it is 5 plus 2 minus 1, 4. So let's find 3 cross 3. Find adjoint for A. 3 minus 2, 3, 2, 1, minus 1, 4, minus 3, 2. For this we have to first find minor. Before that, remember for cofactor, there is plus minus plus, minus plus minus, plus minus plus. Remember this scheme, sign scheme. Let's find first minor M11. M11 means 1 means one first row, first column. Close first row and first column. So what left? Find the determinant of remaining matrix, that is 2 into 1 2, minus plus 3 into 1 3. So 2 minus 3 is clearly minus 1. Next find M12. M12 means close first row and second column. Then find the determinants of remaining matrix, that is 2, 2, 2 2s are 4, minus 4 into minus 1, that is minus 4, minus minus plus 4. It becomes 8. M13. First row, third column. Close it. Remaining matrix is 2 into minus 3, that is minus 6, minus, then M21 means second row, first column. This is our second row, first column. This is remaining minus 2 into 2, that is minus 4, minus 3 into 3, minus 9, that is plus 9. 9 minus 4, that is 5. M22. Second row, second column, that is 3 2s are 6, minus 4 3s are 12, that is minus 6. Next M23. Second row, third column, that is 3 minus 3, minus 9, minus 4 into minus 2, that is minus 8, that is plus 8. Minus 9 plus 8, that is minus 1. Next M31 means third row, first column. Minus 2 into minus 1, that is 2, minus 1 into 3, 3. 2 minus 3, minus 1. M32. Third row, second column. 2 into minus 1, 3 into minus 1, minus 3, minus 2 into 3, 6. That is minus 9. M33. M33 means third row, third column. That is 3 into 1, 3, minus 2 2s are 2 into minus 2, that is minus 4 plus 4, that is 7. And cofactor, that is A11, is equal to, use this sign with this. So plus minus minus 1. A12. 12 means this, minus plus minus 8. Minus 8. Next A13. 13 means plus minus minus 10. A21. 21 means minus 5. Minus 5. A22. Plus minus minus 6. A23. Minus minus plus 1. Next A31. Plus minus minus 1. A32. 32 means minus minus plus 9. A33. Plus plus 7. Now cofactor, that is cofactor A is equal to minus 1 minus 8 minus 10, minus 1 minus 8 minus 10. Next minus 5 minus 6 plus 1. Next minus 1 9 7, minus 1 9 7. This is our cofactor. But adjoint of matrix is that is transpose of cofactor. Transpose of cofactor means adjoint A final. Transpose of cofactor means row changes to column, that is minus 1 minus 8 minus 10. Then minus 5 minus 6 1. then minus 1, 9, 7. This is our final adjoint A. So remember that for adjoint of matrix we have to find first minor value, then cofactor. Cofactor is sign scheme with minor, means plus plus m11 minus m12 plus m13, like this. So thanks for watching my video. If there is any feedback or comment or any problem, then do let me know in the comment box. Thank you.